Hello and welcome to today's session of live programming with Neo4j. And I have with me Jennifer Reif from Neo4j. Hi.
Hi, thanks for having me.
Yeah, thanks for joining. It's such a pleasure so far. We'll try. Yeah.
We'll kind of save the evaluation for after we get something going, right?
Right. So I got some things prepared, and we'll do some live coding on an existing project where we implement Neo4j and try this GraphRAG and see how this is going.
Sounds like a great plan.
All right, cool. I'll try to share my screen.
Okay.
And here we go. Okay, so the first thing I wanted to show, just because I noticed it today, is AI4 JVM. I don't know if you know this, Jennifer.
No, this is new to me.
And it's just a little website, but there's a lot of information about frameworks in Java with AI or for AI, about coding assistance, skills, stuff like that. It's just a little collection of information, and I found it really interesting. And there are also a lot of people who are interested regarding AI and Java. So I just wanted to share that. And then we can jump right into this project. Yeah, so this is the existing project that I want to code on today. I called it Quanta. It's basically, like I say here, it lets you find files in a natural language way and summarizes files. So it's basically just a search engine for your files locally. And it works already, but it works with PostgreSQL and pgvector. So there's this front end with Next.js. I coded that with AI because I'm not a Next.js programmer. And it basically just calls a REST endpoint where we have a service layer. And there's Olama running, which is embedding files. No, I think here, yeah. This is better explained. We have this folder watcher, and it monitors a target folder. It looks at the file hashes like every, I don't know, 10 minutes or something, and then sees if a file has changed or if it is new. And if it has changed, it splits this file into chunks, embeds these chunks, and then stores them into pgvector or PostgreSQL. And then the same is happening when you do a request for a file, basically. Okay, and so far I tried to write that down, what I expect Neo4j to do, but I don't know if it's the right way.
That looks pretty accurate.
Okay.
That's where I would start.
Okay, cool. So I have this file or multiple files, and that has a chunk, and a chunk has vectors, or no vectors. Yeah, multiple.
Yeah, vector would normally be stored on the chunk entity itself. So it'll be stored as like a property. So you actually don't need a separate entity for vector, but you could just store the vector as a component of the chunk, like an attribute kind of.
That's already good information. So we have to write this structure together, and then we'll get into that. And I basically want to find out if files have certain tags in them, and then I can group them by tags. That was my idea. So if I have any kind of insurance or something like that, like dental care, then I have this tag, and I can click on it, and I find everything about dental care on my file system.
Right.
That's the idea. Yeah, and basically it works the same way as before. So the file watcher detects files or changes. These files are parsed into chunks, and then the embedding model is vectorizing them and stores them in Neo4j in some way. And then on the other hand, if a user searches for some query, some file, then this query is also vectorized, and we have a graph lookup in Neo4j for some kind of results. Okay?
Yeah,
so
that looks good.
Okay, all right. Maybe just for the Docker Compose file. Mm-hmm. So I have this Docker Compose where I start up a Ollama container. I have two different models running. Where is it? Ollama. Yeah, it's pulling Qwen3 because these two models are running in my graphics card. So there's not much space, but these are running. And I already found that they are not perfect in any way. But I think for this example, we can use those.
Yeah,
and this way, fine. Yeah, we can keep it all local. That's one thing I really like, if it is possible. So this is the Ollama container. Then the database container. We can look at that just in a second, because I'm pretty sure I made some mistakes. This is the backend container, which is powered by Java. It's a Quarkus server, a Quarkus application with LangChain4j. And then I have a front end with Next.js. So if we look at that database, is there... I commented out the health check because I tried it and I thought it worked, but then when I retried it, it didn't work again. So I'm not sure how to find out if it's healthy in an easy
I usually
way.
do like I create like an endpoint, or you can actually go out to like a web interface and connect via localhost 7474, as long as, yes, you've exposed those ports already. So that should be good to go. And I just kind of test that I can connect to the database that way. And that works fine for me. I haven't done the health check specifically because I can just pull up a browser to test it. And usually you'll see the container. If anything goes wrong with the Neo4j container, it usually just shuts down. And so you'll see it not running anymore.
Easy. Okay.
So yeah, that would be the biggest hurdle, I think.
Okay. Yeah, that's why I changed. Before I had service healthy as a condition, and now I changed it to service started. So that should be enough anyways.
I think so.
And then you have to use that user, but you have to use a different password than Neo4j.
Right.
Yeah.
Yeah, it'll require you, because of the container, it'll require you to basically reset the default password. So that's all you're doing there, is just resetting the default.
Yeah. Okay. So that's
otherwise
enough
it'll
for
complain.
that example. Yeah, exactly. That's what I tried first.
Yeah.
Okay. And I mounted that data directory.
Perfect.
To a local file.
Okay. That looks good.
That's about it. And these two ports, I think one is for the actual data connection and one is for the browser, basically.
Correct.
Right?
Yep. The 7687 is our bolt port. So that's your typically your programming language port, where you pass queries either with Java or Python or whatever language you might be using. So when you connect via the driver, it's the default to use the bolt port connection. But then if you just want to interact via like web browser, we also expose port 7474. In order to visualize the data, you can kind of play around with some queries and just get a feel for what the data looks like.
Yeah, I'm excited to see this. I didn't try it yet. So this is what it looks like right now.
Perfect.
Exactly. Okay. Okay, so far so good. That's almost everything. And now we can go into IntelliJ and Quarkus backend. Where would you like to start? I think modeling of the data structure would be really important, right?
Yeah. So that would be
what I already added was some dependency.
Yes.
Yeah, this one.
Okay, perfect.
This was all I added.
Okay, that should work. There is a Quarkus Neo4j. Well, actually, that would be, there's a LangChain for J community, which you probably already have, the community and then the core. So there's 2 different libraries.
Yes, there is.
So that wouldn't be Neo4j specific. It would actually be LangChain for J specific. And sometimes there are updates, especially to the Neo4j stuff, that drop into community first, but then takes a little bit to get propagated over to core. So that would be the only thing, is if we run into issues, we may want to see if there's some new updates in the LangChain4j community package that maybe just haven't been pushed over to the core yet.
So is there a specific dependency that we need, or
no? I don't think so. I can double check. I'm trying to remember what I've done before. I've got a couple examples on my GitHub of this as well.
This one.
Oh, there is actually a Quarkus LangChain4j Neo4j dependency as well.
Okay, Quarkus Neo4j LangChain.
Yeah.
Okay.
Oh, I have a frozen screen. Anybody there? Hello?
Yeah, sorry. There's something very wrong with my PC right now.
Oh no.
One second. I'll try to unplug and replug some stuff.
Okay.
Okay. You can't see me, right?
I cannot. No. There must be some wider spread issues going on, because this exact same thing happened to someone in my last live stream.
Really? Oh man.
Yes. Okay, your screen is showing now. And that first link looks correct.
Now you can hear me.
Yes. Hello. Oh. You're back.
Great. Oh man, sorry for that.
No problem. That first link looks right.
Okay. That looks good. So we're gonna add this as well. go. Yeah. Okay. So, yeah, I already have a structure, but I think we have to remove it or change it. Storage. Oh, yeah, there it is. So okay. This is my only entity, it seems like. Yeah. Before. But I don't think we have to think much about that. I think we should just start new, start fresh.
Probably.
But I really don't have the first idea how to start with Neo.
Okay. So I would recommend, let's see here. So you have data in your data folder, and it's just a series of like PDFs, correct?
It's a mixture. Yeah.
Okay.
Let's look into that. 1 second. Yeah. So I have these resources, I think, demo files. Oh, so perfect. These are all AI generated nonsensical files. Yeah, this is a text file. Sci-fi, there should be, yeah. There are even some images, but there's nothing to do with them. So far, I thought about like extending it at some point to analyze images as well. But basically, yeah, this is what I have. So a PDF of some kind.
Okay, and right now, how are you parsing that PDF?
Yes, I have Tika, I think that's the name of it. So text extractor service.
Okay.
And I think that's using, yeah, this Tika to just extract all the text from it. So basically what we have is text from some files, yeah.
Okay, and then the actual ingestion, let's see, you've got an embedding service. So that just creates the embedding, right? And right now that is going to PG vector, correct?
Right, yes.
Okay. So yes, you'll need to change that out and swap that to a Neo4j vector embedding store.
So, oh, okay.
Okay. And yep, that should work. And
oh, it's 100% compatible.
Yeah, I mean, cool. Sometimes you get fortunate on that. Yeah. Yeah, and I mean, we can start with the kind of generic, I guess, entity outline you have right now, the object format. We can work with it as we go. So really, just dropping this into Neo4j just as a substitute swap in and out is going to create the entities, which Neo4j operates on nodes as your entities. So they're kind of like, I don't know, I guess you could think of them kind of like objects, but they're siloed, just like you would have, you know, a row in a relational database or a document inside a document store. The real value is in the relationships, but let's just see if we can drop the, just swap one for now and just get the chunks into the database as is. So the other piece we're going to need is the, where else will it save to the database? Go ahead.
This is the only entity so far. And there are these tags, but they are not, they were an afterthought. So they are not in any relation to one another or something like that in Postgre. But I would like to have that in Neo4j.
Right. Okay. So for that, you would need some sort of extraction service. So if there's like a large language model or something that we can use to abstract or extract that. Sorry.
Yeah.
I know we have some Python libraries for this. I'm not sure what's available in Java, but I can do a quick little search on that. As far as, oh, look, okay, yeah. So you actually have a prompt for this, which is helpful.
Yeah, so that's just a simple way.
Okay, yeah, again, that might work. At least starting out, we can give it a shot and see if that does enough. Okay, and then let's see, where will it do the? That's the tag and relation. You've got a summarizer service. Where does it actually store? Because I know it'll do the embedding piece. Is that also where it stores the entities themselves?
That's the repository. Oh, what do you mean the store?
Like to actually store the entities to the database.
Yeah, so that's the repository here.
Okay, all right, great.
So there's save metadata. Yeah, so that creates an object, an entity, and then it persists it through that Panache repository.
Okay.
What a panache! I'm not sure how to
something like that. Yeah.
That. Yeah.
Okay. All right.
So, yeah, that's it.
I mean, I don't see errors, so maybe let's see what that does.
But now, no, this entity is for Postgre.
Ah, correct. Yeah. So we need to change that.
Yeah, we need to change that. And yeah, I don't know. So I read about that there is some object relationship mapper just as Hibernate available for Neo4j as well, but I don't know if we should use it or.
Sure. I've used it in several of my projects. So it's just the Neo4j OGM Quarkus dependency. So you'll just need to add that as a dependency.
Okay.
And then we can map directly to our Java objects.
OGM?
Mm-hmm. So like you would have an object relational mapper.
Yeah.
Yes, it's object graph mapper.
This one.
So it actually should be Neo4j OGM Quarkus. So there's a Quarkus.
Quarkus. Oh, all right.
Yep.
Okay. Let's see.
There we go. Yep. That's what we need.
Ah, yes. But this is not, that's from 2022. That's,
yes.
Okay, so it's just not changing. Everything works. No. I think I had the wrong one. That's this
better.
One is better, right? Yeah.
Yeah. I wonder
okay,
when that changed.
I guess like 4 years ago.
Oh, that's interesting because it's the same name, isn't it?
No. 1 second. That was very different. So that was from Michael Simons.
Oh, it's been relocated. Yeah, because because it's now officially supported.
Yeah, that's
okay.
Good.
Sorry about that. I didn't catch that.
Oh, good. All right, back to the POM. Here we go. Don't like this. Don't like that. Okay, and back to the entity.
Yes. So now you should need, I think it's at node entity, if I remember correctly. Yeah. And then you shouldn't need the table name at all.
Yeah. Okay.
Perfect.
Yeah. We probably don't need that as well.
Probably not. And then.
Well, these names are not necessary anyways.
True.
So, a column, a definition, is that necessary?
No.
Cool. The less code, the better.
Uh-huh.
But this one, so there's like this unique qualifier. Is there something in Neo4j that's like an ID? Or
So let me check that. I think it just the at ID should be fine, but let me see. Oh yeah, you've got the persistence ID. So it should be, there's an OGM annotation for ID. So if you just change, yes.
Yeah,
that's the one we want.
That makes sense.
So then it should take care of the rest of that for us.
Cool. Okay, and everything else is just noise. And
yes.
Yeah.
Now, do we want it to save as file metadata, or do we want it to save as something else? Because it will create, basically what it'll do is it'll create an entity using file metadata as the label, or working with tables, it kind of lines up to like a table name, if you think of it that way. So as long as we're good with that, then we can just stick with it as is.
I think it's not a bad name because it's not directly a file. It's the data around it. So
sure,
there's a summary with it and vector UUID. I don't remember that one. But the last modified is important because we want to see if it has changed since the last time we scanned it.
Okay.
Yeah.
And right now, the full file gets automatically, or when you had it in Postgres and PG Vector, it would get chunked up, right? And
yes,
and saved as a unique chunk for that same file, correct?
Yes.
So go ahead.
Let's see that really quickly. So there's this file watcher, and that is scheduled every 10 minutes.
Okay.
And it just walks through all the files in the given path, and then it ensures the metadata and on file changed. It does something. So yeah. So it extracts the contents from the file.
Okay.
And then it is, if it is not blank, it summarizes the text.
Okay.
It tags it. It's generated tags. Yeah, again, tagging. And then we have the embedding service, and that's where we want to see what happens.
Yeah.
Yeah. So there's a text segment with the content and metadata from the path and the summary.
Okay.
And then everything, this is the embedding. Ah, yes. And then it is stored in this embedding store. And that's a different table from the file metadata.
Oh, okay.
Yes, that's how it worked. But I don't have that as entity. And yeah. Now I remember. So the UUID was the one making the connection from the embedding. So I'm looking for that embedding. If I search for a file, I look for the embedding, and then I take out the UUID for it and look for it in the database. That's how it went.
Okay. So I know we won't need that approach for Neo4j because it all gets stored together.
That's nice. That's good.
But figuring out what we will need, that is going to be a little bit of digging, I think. So let's see here. I'm just trying to think what to dig in on first here. So we probably need, in the file metadata, we probably need to have a place for the embedding. So you can probably get rid of the vector UUID, but I would maybe just put embedding instead of that. And I'm trying to remember, now that we have the new vector type, I'm trying to remember if there's a specific data type we need to use for that. Let me see if I can quickly look that up. Vector. Okay.
There's a Neo4j vector.
Oh, perfect. That's probably will cover it.
But is it the bold one?
It's probably the driver type at the bottom.
Okay.
That would be my guess. We can start with that, and if it goes terribly wrong, then we can switch.
Neo4j vector type. Okay. So far, so good. Can be created using following methods. Okay. That sounds about right.
Okay.
I'm not sure if we shouldn't define a specific vector and not just an interface, but not sure on that.
I'm trying to think. I'm looking right now at what they. Let's see. It looks like there's several supported types, but I don't know what it creates by default. That's what I'm trying to figure out.
Doesn't it depend on how you call that one? So if you call values vector with a double, then it's creating this one, and so on.
Yeah, I don't know what it'll create by default though. So if we send it the data and it creates the embedding for us, I'm not sure which data type it saves by default, I guess is what I'm looking for.
Okay, so yeah, I have no idea how to use it. So we have that embedding store, and we maybe this is the wrong approach then. If there is this embedding store, that would suggest to me that this is a separate kind of object tree, a separate store from our node entity.
This really is just specifying what type of entity we are saving as. So since Neo4j stores the embedding as a property of an object of an entity, then embedding just becomes an attribute of whatever entity we're saving. In this case, it will be our file metadata entity.
Okay.
So embedding is just a property on that. It's an attribute. So we have to define the embedding. Otherwise, when we save the file metadata object to Neo4j, it won't save the embedding as part of that.
Yes. Okay. Understood. Yeah. So we have to configure the embedding store.
There's a couple of properties that you will probably need. One would be like an index specification. I'm trying to look. Yeah, it does create a default index. I'm trying to think now. I think Quarkus should auto create a default index, so you shouldn't have to specify it.
Okay.
But you probably need to specify the label, because I bet that will be defaulted and it will be something other than file metadata.
Yeah.
Default, let's see, label.
Well, that's a good example. Dimensions. Okay.
Yes. Yeah. So that would be. So yeah, that's the configuration for creating the embedding store itself. Since you have the annotation though, unless we're wanting to configure something separately, then we can just use the default. And I think you already have the dimensions outlined in your properties file. So you shouldn't have to create like a separate config for that.
Okay. But maybe we have to rewrite it.
Correct. No? Yeah, because we'll need to change that. It should be Neo4j, I think.
Of course. Okay.
Yeah, Neo4j dimension. Perfect. Yeah. Yeah, I thought it was the same name path. I just had to check it.
All right.
Okay, so the default is document. So we will want to change that to file metadata.
Yes, let's do that. Yeah. Almost.
Wrong property.
And then, yeah.
Perfect.
Well, that auto-completion is nice.
Yes, it is. Okay.
Yeah, I should probably also configure the connection.
And
now,
how is this being used?
This
JDBC.
one?
Yeah.
It was also with the repository that was automatically used through Quarkus and the Panache
okay.
repository.
So, perfect. So since we have a Neo4j dependency in our POM, we can just skip the JDBC and we can use the Quarkus.neo4j. And we can use the URI. Yeah, you'll want the username and password as well for that. Oh, yeah, there's the URL.
That's a URL?
Yeah, it should be URI. There it is. Okay. Yep. And then you'll need the username and password defined as well.
How do we...
so it would be Quarkus.neo4j.
Oh, yeah, okay. Yeah. I thought I should write it in the URI. So,
no. Nope.
Okay, this one and...
Yeah, just configuration parameters. Yep, exactly.
And I think that's not secure.
Correct.
So this one is gone. We don't need this anymore.
Nope.
There's no database name.
No, it'll default to Neo4j, I believe. So you shouldn't need to specify it.
All right.
Although, let me double check. So you will need it for LangChain4j, though. So there's a Quarkus LangChain4j, Neo4j database name.
Okay. For what? What is
so Neo4j supports multi-database. And LangChain4j requires you to point out a specific database. I found this a little bit odd too, because if you're just using Quarkus, it doesn't require you to specify a database. It'll kind of default to Neo4j, and then you could specify it, as needed. But LangChain4j apparently requires you to. So if you don't define it, I think because of the using the embeddings and maybe it's because of like PG vector, you said you had to define a separate table for your embedding versus your other. Maybe that's why they require the database name. I'm not sure exactly, but yes. And you'll need to set that as Neo4j for the value.
Okay.
Because it all gets stored in Neo4j, it all gets stored in the same place.
We can all see this in the with the browser, right? All these relationships and databases. Yes. Okay.
Yeah. When you store the data, you can look at it.
Okay. We don't need this
that
one
either
anymore.
Nope.
But this one I think is valid. Okay.
Yeah. Everything else I think looks good.
Great. So, okay. So we don't need to change any of that. Possibly.
I don't think so, at least not starting out. Let's see where it kind of complains.
Yeah. But now we have to go to the loading and storing, right?
Right.
That's
something
we have to do at some point.
Yep.
And that's probably very different.
Let me look here.
So there's this persist method from Panicky that does all the heavy lifting basically, and there's also I believe a find by ID method. So this is this repository pattern with the same with Spring has the same one.
Right. Okay. So let me check here how we need to go about that. Because the times that I have done this previously, I have typically done a like preload the data to the database itself. and then just read that data from the application. So actually figuring out how to store that data is something I'm checking on. So
cool, great.
Okay, let's see. Okay, yep.
This is embedding store. Anyway.
Oh, perfect. Clean up code while we're at it.
Yeah. Looks like, yeah.
Okay, there should be, it says an add method.
Where? We probably need to implement or extend something.
Yes. Yeah, let me look at that.
Neo4j repository. Nah.
I'm trying to look for it. It's not there. It is. There's the Quarkus documentation for it. That's what I was looking for. It didn't come up.
I often have problems with finding documentation with Quarkus.
Yes.
Really.
It gets buried.
Yeah.
Okay. So, yep, the embedding store.
That's not right.
Okay, so this just shows, and let me look, because this actually looks incredibly similar to our embedding service. So I'm wondering if actually we can consolidate. Because this shows. Okay, this just shows a straight service that just does the embedding and everything all in one. So you would set up an ingester, basically, which is kind of what you're doing with the, yeah. And instead of this embed, it would be like an ingest, and you would have documents that get embedded. Let me just send this over really fast in our chat.
Oh yeah,
it kind of shows it better just looking at the documentation.
Let's see. That's what we have.
Yep. And yeah, this usage example was kind of what I was trying to step through a little bit.
Yeah.
So this to me looks like a combination of your embedding service plus the repository. But does that look accurate to you?
So is a document something that's defined by us, or is that?
That's
no.
Like a default. Yeah.
Yeah. Well, it's a default, but it's very similar to this one. I had to put this text stuff into a text segment. I think that's very similar. Or maybe.
I think you can avoid all of that, though, because I think since we have defined the label as file metadata, you should just have to reference, hey, ingest the documents as file metadata entities.
That would be too easy.
it does look easy, doesn't it? That's suspicious.
Yeah, exactly. Okay, let's try that. So we have that embedding store, and I don't know what that does.
So recursive is basically going to say, hey, you have 500 chunks, and you're going to have 0 overlap of the chunks. Now, typically, we do recommend some kind of overlap because that's what most people tend to do when they chunk things up. But that's totally up to you. We can set it. We can leave it with the default, and then we could always adjust it as needed.
You have much more experience with this. So if you say 100 is good, we'll do that.
Yeah, let's do 100.
All right. Okay, then we ingest that, and we don't want to ingest anything, but for example, no.
So I would, let's see.
You would probably just put in the file metadata. That's what I understood. What you want to do.
Yeah, that looks.
But I don't think this will take that.
Yeah, so you'll need probably a list of document, but list of file metadata.
But this is not typed. It really just takes the type document. So there's no generics involved in this.
Correct.
Right?
Correct.
So what I have to do, I think, is create a document, and then you can say, document from some text. And then I can put in this, for example.
Okay.
And so this is very, very similar to what I try to do with this one. I think.
Okay.
The text segment, can you put this text segment in there? No.
Oh, no. You could do it from and pass the text and the metadata, though.
Yeah. Okay. So given that we get file metadata here, right? That's what we would like.
Correct.
Then we could take this one and just say get the summary. No, we don't want the summary. Yeah, the file metadata doesn't even have the complete text because it didn't need it. And I don't think it's a smart idea to store all the text of all the text files that should be searched, right?
I mean, that's entirely up to us, I think. Really? I mean, I normally. So when you well, let me think about this.
So the way I see it, so I have a huge file tree. So what I had in mind was really all my personal files where I have a lot of documents about insurance and stuff like that. I want to extract all the text and then make the files searchable. And I don't need to have the direct text passage or something. I just want to find the text file or the files easily. So I don't have to store all the texts that I extracted from any file. I just want them to get found by vectors, with vectors.
Okay. Okay. And that, so I think probably what we want is to store the file metadata as the chunks then, and leave the I'm trying to think how, because that's not overly graphy in that case, but we could start from that point. So we can store the embedding of the text and the file metadata as a file metadata entity. So that should be fine. So I think that is fine. It's just then figuring out how to convert the file metadata into the expected list of documents, because that's what ingest is looking for. And there's a way to do this, because I've done it with other frameworks before.
Okay.
And I'm just trying to figure out how it's done in Neo4j, how they handle that. Let's see here.
Yeah. So the ingester, of course, takes some text. So, yeah, it takes some text and basically vectorizes it, right? That's the purpose of the ingester.
Yep.
But in my opinion, we don't want to have the object in there. But I think that's where you're trying to get, because we want that GraphRAG. We want to have these objects vectorized and not just some text without any relation. Is that
so? We typically store the vectorized version of text on the entity, on the node.
Yeah, okay.
So so what I'm trying, I guess, to get at is we need to store the file metadata chunk, is basically what it is, right? It's a chunk of the original full document.
Yeah.
We need to be able to store that, but the vector should be a piece of that. It should be included in the chunk itself. So you don't have to store the text necessarily of that chunk, but you need to store the vector as part of that entity.
But I think what I did before is I take this, for example, this whole content and some metadata, like stuff that is also in the file metadata, vectorize that, and that stuff we could put in the vector of the file metadata, so it's easily found.
Okay, so you want to not just store the text, or not just vectorize the text, but you want to vectorize the path and the summary as well.
Right. Yeah, that was just an idea, so that maybe it's more easily found, but we don't have to do this. The important part, I think, is the content, that the whole text of this file is chunked and stored as a vector in the file metadata.
Okay. So in that case.
But I still don't understand how we come from the ingester to our object, the file metadata. That's still something that I don't fully grasp.
Yeah. I'm trying to look at examples too of how it has us doing this, because everything that I've worked with, again, is to store the entities outside of the application process and then just do the retrieval from the application. So I'm just trying to figure out how to, from the application through LangChain, store the actual entity into the graph. Let's see. So I have the embedding store, and I see examples of searching the embedding store, but I don't see examples of actually storing to the embedding store. Yeah, let me see if I can find a couple other things here. Okay. Okay, that looks good. Okay. So this is actually using, I'm looking at an example right now that is taking text segments. Okay, that actually looks much simpler than what I was trying to think of, which is good.
Right.
We like simple.
Yeah.
So this shows, let me send the blog post over.
Yep.
I think that's easier.
Okay.
And scrolling down to where it says store embeddings.
embedding store instances. No.
Keep going a little bit further. There it is.
Embeddings.
This.
Okay.
So yeah, you're just taking the text segment basically, which would be content in our case, plus the path and summary that you were wanting as well. You would just create a text segment from that.
Yeah. So that's what I did before as well, basically.
Okay. Perfect. Mm-hmm. Then yeah, it looks like it's nearly the same for this as well.
But then no, it's basically the same.
Yeah. I was thinking we were looking for the entire object, but it doesn't look like that's the case.
Yeah, but there's no object there yet. So this is querying, okay. Yeah. And then it gets the relevant text segments back out. Mm-hmm. That's good.
That's the retrieval piece, yeah.
Yeah, but I don't want the store. Yeah. Okay, and then, So this looks exactly the same, like I did with pgvector. So the embedding that it found, the embedding match, mm-hmm. has a text segment which is red, and that was basically my UUID. And with that UUID, I could retrieve the object from the other table.
Okay.
That's what I tried to explain in the beginning. And that's what we could do with Neo4j as well, but that has nothing to do with like GraphRAG, right?
Right. Yeah, for GraphRAG, you would need to store the actual chunk, the text segment in this case. Mm-hmm. And then you would need to store the file metadata entity. So the URL, yes. The path, the whole document summary, etc. Yeah. And then you would need to create a relationship between the chunk and the document, the file metadata. And that relationship you would traverse. So when it retrieves the chunk from the embedding match, mm-hmm. then it will need to actually go out and grab the related entity for the document metadata. My hope was that we would store the chunks first and just get that piece working, and mm-hmm. then go back and add that relationship.
Okay, let's do that. Right?
Yeah, sounds good.
That shouldn't be too hard. So we can erase that again, because
I think so.
So we got all of that, and we can erase the metadata. So we only have the content of the text, and we embed that.
Are you creating the embedding from the content plus the other stuff, though? Or are you
That's
just
what I used to do, yes.
Okay.
But we don't need that anymore.
Okay.
Right?
Sure.
Let's keep it simple, because we want to add some object to it.
Okay.
So this line should look a lot like this one. Yeah, so we have that store already, and we have that. Well, we have that model. We inject that, and then we create a text segment from it, and embed this and get the content. And we do that in one line. Create the text segment.
Perfect.
Embed that and get the content of it.
Yep.
All right. And now the embedding store, was that here as well? No, storing was not. Why is there no store?
So you add.
No, well, sorry. There is an embedding store, and yeah, you add, exactly.
Yeah, you have to do the add, yeah.
And I don't want to have all of that anymore. Again, let's keep it as simple as possible so we can.
You'll need the embedding and the text segment.
And it's just all add.
Oh.
Right?
Right, because you're not wanting to keep the actual text around, correct?
Well, I don't know. For now, I don't need it.
I normally save the text alongside it just
right,
because when you ask it questions, it will actually retrieve the chunks, so you can verify the data that's coming back.
But that's actually not a chunk, that's the whole content. So that will be won't be that great.
Too true.
But something is not working. Why is it? Oh yeah, because it's a text segment. It must be a text segment. That's why.
There we go.
Text segment, yes, and put it here and there. And
there we go.
Good. Okay.
Now it's happier.
Yeah. Okay, so that's it so far for the embedding.
Yeah.
And to retrieve, well, get similar files, that won't be possible now because we have that text. We could get, we can get the content of the file, but we can't get the file right now. That's
correct.
why we need some objects.
Right.
But basically, so was that the same here for searching? Embedding search request? Yes, that sounds correct. Matches.
Search. Yep.
And then search request makes results 10. Okay. And then it gets the results, sorted by score.
Okay.
So this is embedded. Yeah, so that's not what we want anymore. I think. No, embedding match, sorry. No, embedding gets the text segment. And then from that text segment, we extract the text. So what that should return is 10 different contents of files.
Yep.
Okay. Okay, so shall we try it or just pretend it works and go from there?
No, let's test it and make sure before we move ahead.
So let's just erase that. Yeah. Because at some point we have to probably rewrite that, but not now. Yeah. And we'll get a list, and this list is actually the contents. And I could just pretend this. No, I cannot pretend this is file metadata. Well, I can. Let's just map it. So this is file content. And we'll get an optional of, and then this is the file content. Get this, but then we have this. No. This is too complicated. Sorry.
That's okay.
Yes, this one. So we have the file content, and then I just have to create some kind of file metadata DTO with the file content, and let's put it in the summary. Everything else is just empty. And does it go on tags and relations? These are one again. Okay, so it returns file metadata DTO with just the content of this file, just so it compiles. Find files. Well, that's just returning an empty list. No, wait a second. Let's put it here. Yeah, let's just put it this way. Okay, does it compile?
Come on, IntelliJ.
I don't know why it's taking so long. That really shouldn't take a long time.
Yeah.
But we can already start that backend and build it. Oh no, we can't build it. Okay. We have that repository. Yes, that is removed. And we don't need to do anything here. Just ignore the tags for now.
Okay.
I'm guessing this is a similar case. Yeah. And oh, well, okay. Ensure metadata is not that great. Ah. Will be all right. Maybe no metadata. Oh, yeah. Okay. Return no. Yeah, I'm not sure if this is going to work. And the vector UUID is gone.
Yep.
Hopefully we don't need it anymore.
Shouldn't.
Yes,
that's the thing about Neo4j is that it does not require a technical key. So you don't have to have a technical primary key.
Yeah.
You can use a business key, basically. Just whatever might be unique. And if you don't have anything unique, you can create something like a UUID or something that makes sense. But you get to choose that. It's not required.
Yeah, that's interesting. I worked with Eclipse Store a lot. Do you know that one? So that's also an object storage, but it's native to Java. So it maps all the Java objects that you want to store.
Okay.
Maps it to the file system, basically.
Oh.
And that I think has a lot of similar pros and cons like Neo4j. So for instance, what I think I found out is that Neo4j has quite a lot of boot up time if you have huge databases, right?
Okay.
So because you have to load all that, all the objects in. Is that the case?
So like the basically like the data preparation phase, is that what you're talking about?
Well, the preparation in the sense of I'm booting up my Neo4j server.
Oh, yeah. A lot of that is handled at the very beginning of the phase. The power comes from, because you're storing those relationships at write time, then your query time is much faster. And you can create like in-memory representation, so kind of like a caching of some of the data for queries that you run consistently, and those can run hot. But of course, you probably don't want your whole graph to do that, especially on a really massive data set. So it just kind of depends how you want to optimize that. There's lots of different ways to go about that.
Yeah, okay. All right, so on file change, we need that UUID. Let's just I'm not really sure if this still works.
Yeah, we'd need to figure out for that file watcher, we would need to look for, we'll have to figure out how to store the file metadata and to check for changes.
Yeah. Otherwise I think we going to have some problems. So just spinning up the backend, and what it does is it executes a Maven build, and then it starts up this build jar. It shouldn't take that long as well.
Build success, that's good news.
Yeah, that's good. And the starting of the actual container should really be fast. Yeah, it's building the container. Okay.
There we go.
Yes, that sounds good.
Uh-oh. Okay. Oh, is the dependency still there? Or did you remove the PG vector dependency?
Yeah. No, I did not.
So that's probably, yeah, if you've got the dependency in there, it'll look for that.
Okay.
That, because that's the same thing with Neo4j. Neo4j does the same thing. If you have the Neo4j dependency, it looks for that Neo4j dimension in there.
Oh, okay. So we don't need this as well. I can clean up a bit. This one and this one. Okay. That seems about right. Cool. So let's try to build it again. Okay, what I will be really interested in is these relationships, because we don't have any relationships yet, right?
Correct.
But we will have some with maybe the tags or the chunks.
Yeah, right? Probably. We'll probably start with chunk first, and then we could add another entity type for tags as well.
Okay, that's good. Because I have lots of problems with Hibernate and these many-to-many relationships or many-to-one. I constantly get them wrong, and then I don't know when it is lazy and when it is not lazy and stuff like that. Yeah. And I think Neo4j is much easier to understand in that regard.
Hopefully.
Yeah.
Hopefully. Yeah. That's the plan. Uh-oh, what didn't it like?
Null point. Yeah. Okay.
Yeah, the metadata.
Yeah, so maybe we should find a way to store this metadata.
Yes.
Do you think we need this eventually, or do you think we can work around that?
What all the time? The tags or the metadata?
The metadata. So do we need to store the file metadata explicitly at some point? I think so, but I don't know if you...
Probably. I mean, I typically do. I store it as like a document node, or in your case, it would be file metadata node, or I've stored it as like a blog post metadata or something like that when I have that. Now this looks like, I've completely forgot about this in LangChain4j. So they have a KnowledgeGraphWriter class.
What? I don't know that one.
Yeah, I'm trying to find the documentation for it right now. Okay, now that's LangChain. See, that's the confusing thing too, is everything you try to search on LangChain4j, it always comes up with LangChain first.
Oh, yeah. Yeah.
Like, you're right. No, that's not the right library. It's totally different. I'm trying to look for, yeah, it's got the embedding store, but what we really want.
I think we have, yeah.
Okay, KnowledgeGraphWriter is a utility class for writing structured knowledge graph data to Neo4j. It's designed to work with data produced by an LLM graph transformer, which extracts nodes and relationships from unstructured documents. This writer is particularly useful for scenarios where textual data has been transformed into a graph structure and needs to be stored efficiently in a Neo4j database, including optional document provenance. Okay.
That sounds good.
Yeah, it does. I'm trying to figure out how do we implement. Of course, it doesn't show a full example anywhere. Let's see. It looks like, though, let me just see if I can grab the tag here because it's actually in the repository. Okay.
Okay, KnowledgeGraphWriter.
Right. So according to that, we need to somehow create a
okay.
Graph document instance.
Yeah. Okay. Oh, that sounds interesting. Okay. So let's get back to our embedding service, because that's probably where we need to use this. Is that even available? Maybe I need some dependency.
This looks like it should come.
Oh man, that's a long file.
Oh, this might be the LangChain4j community Neo4j dependency.
Hopefully that's not something from Spring Boot.
No, so that's just if you want to use the Spring Boot starter, which we are not.
All right.
So you can skip that one. Yeah.
Cool. We'll go into this one, and then we'll find out the latest version of it.
So the LLM graph transformer is database agnostic, which means it transforms text into a set of nodes and edges that can be used for other graph databases as well. That's interesting. I had no idea.
Yeah. So this is that one, and we need this one as well. Go. Yeah, okay. Same version. Okay. If it is synced, then we can go back to the embedding service, and then everything will turn out to be great. Yes. Ah, we got something.
Yay. That's better.
Yes. And the graph document as well. Ha. Obtained from LLM graph transformer.
Right. Which I'm trying to figure out how to call that.
Mm-hmm. Yeah. Okay.
Okay. The next step is constructing knowledge from text chunks. We use an LLM to extract structured information in the form of nodes and relationships from the text. You can examine the LLM prompt. Okay. But how do we do that? In Neo4j, because it's showing a Python example. Not super helpful.
Oh man. Okay. Graph documents. So, okay, let's look for a LLM graph transformer for Neo4j. Yes, something. No, I don't think that's the one.
Figure.
LLM graph builder. There's a repository.
Yeah, that's a separate app.
Okay.
So, I mean, that would get like an initial load, but that wouldn't help us so much on the file watcher stuff.
Hmm. Again, LangChain.
Yeah, there is not a ton of documentation or examples out there.
Yeah.
For creating like a full graph.
We don't need a well, we need a full graph, but it shouldn't be big or anything.
Right.
It would be enough to just have a simple relationship. Hmm.
Yeah, I can see that's just the content retriever. That's not helpful.
Okay, maybe we can build a graph document ourselves.
Yeah.
From document source.
From document source. That might work.
Okay. Or from a set of graph nodes and edges. That would be something. Right? If we have
to define all of the
nodes and relationships. So our well, let's see what that is. Set of and then graph node from ID. Oh, okay. What does that ID define?
Yeah, so this would be like your entities that are already in or the entities that you want to store as a graph. So you would have to map your document pieces to the file metadata and or a chunk entity.
So I could take, if I have existing file metadata, I could take that metadata.id or something like that.
Yeah.
That could be enough. And then if we have like a tag, a chunk, but do we put these chunks in there? I'm not sure.
So yeah, so your model would basically be something like file metadata. In fact, we could back up a step and actually just define our data model. So going back to where you have storage, you've got file metadata.
Yeah.
And then I would create a separate entity, separate class, if you will, and name it chunk, for instance.
Right.
And then on that chunk, yep, exactly. On that chunk, we would have probably the text, the embedding.
That vector, right?
Yes. And that's probably it. You would need an ID though. So I would set up like a... Yeah.
Okay.
I think, I guess we could set a UUID or something for that.
This one?
Yeah.
Okay.
Okay, that might work. And then, so back to our file metadata. Yeah, go ahead and remove the vector because we're not going to store the vector on this now.
Okay.
We'll store it in chunk. Right. And yes, you will probably, though, have a list of chunks because if the document is getting chunked up.
Yeah.
So you'll have a list. And then to annotate this, you do @relationship. I'm going to double check my syntax here.
Relationship outgoing.
Yes. Yeah. So it would be, has chunk. Yeah, chunk probably. Yeah, that sounds good.
That relationship outgoing, what does that say? It probably means that one metadata is owning multiple chunks.
Correct. Yeah. So you have a file metadata. So for instance, your title, when it was published, whatever that might be. And then for that document, for that file metadata, you have multiple, for lack of a better term, chunks of that document that are segmented out, right?
Yeah.
So then when you do a search, it'll retrieve a chunk, but it could go back and grab the relationship, traverse that relationship across to the file metadata for all of those chunks technically. And you could find, previous or next chunks or similar chunks within that same document or what have you.
Yeah. But so I would need a relationship back to the file metadata from the chunk as well. No.
Nope, because by default, it's bidirectional. You store it in a particular direction, but it's traversable either way.
And I don't write that. So I don't see any file metadata here.
Well, probably what we need to do is actually store the relationship in the opposite direction. So from chunk to the file metadata, because when we do a search, we will probably find related chunks.
Yes.
And in order to traverse to another entity, we need to have the relationship pointing from chunk outward or from chunk to the file metadata. So you would define @relationship on the chunk here.
On the file metadata.
Right? Yep, file metadata. Yep. And then you would define @relationship. And
but that's outgoing now.
Yeah, we can define it either way. That's fine. But then I would rename the relationship. I would say instead of has chunk, like has metadata or has file metadata or something.
Data. Okay.
Yeah. And then just remove the relationship on the file metadata side because I don't think you'll want to search back the other direction and remove the chunk as well because you don't need to reference that.
Okay.
From this side.
Yeah. All right. Yeah. Got it. Why is that red? Must be constant. Well, it is.
Yeah, it is.
Maybe it's just working through some stuff and it will eventually be fine. Sometimes that does work. Yeah, okay. So we just imagine that this
I think it's relationship.direction.outgoing. That might be what it's picking about. .direction. There it is. Yeah.
Great.
It's happier.
Great. Okay. No, you wanted to go back a step. So
okay, so now we
that
have
relationship,
the individual chunks, and we have the file metadata associated with those. Do we want to go ahead and outline our tags?
Yeah, let's do that.
So are the tags part of the text chunks, or are they part of the overall file metadata?
I think they are part of the overall file metadata, because that's something that we extract before any storing. We extract those tags and just store them so we can find files with that tag.
Okay, perfect. So then define another class and just call those like, yeah, tag. Great. Love it. Okay, and then same thing there. Yep, node entity. And then we'll probably have like a string name probably. And we'll probably want to define an ID as well. So same thing, probably like a UUID or something there.
With the add ID, yes. And then I want to have references to those files. So I want to have a list of file metadata.
Yep. And then you would do an @ relationship. Yeah, once you import that. Perfect. Okay, now here's the question though. How do we anticipate querying this? Are we probably searching for a tag and pulling related files for that? Or are we searching, like when we do like a GraphRAG question, so we're pulling from chunks and we need to surface tags from there? Or like, how do we anticipate, like what's the entry point, I guess, into our graph?
So I would have thought about that, that we are looking for some file. Okay. And then we get a list of files, and I click on the first file, and it will give me a summary and some tags. So a file has some tags like related to dental insurance.
Okay.
And then I can click on that dental insurance, and it will give me all the files related to it. So I want to search both ways.
Okay.
Actually.
Let's start in one direction. We can always add another direction in a little bit. So let's start from, we probably want to start from the file metadata, right? And grab the related tags from that. So I think I would define the relationship, this direction. Yeah, so just add, exactly.
This one.
And add a relationship there.
Yep.
And it would be, probably like a has tag. Perfect. And just remove the reference on the tag end for now.
Oh, okay.
Yep. Yeah, we'll start here, and then we can always add on.
Right.
Okay.
Okay.
Now with that.
Yeah. You go ahead.
I'm trying to think where we should start or where we should dig in next. What would be the next thing you would want to, I guess, implement from here?
I want to have those relationships embedded. That would be my goal for today.
Okay. So just getting the document stored then at this point. Okay. So with that, now this is the tricky part, because we need to figure out how to, from our documents, create a graph document from those.
Would it be like the next easy? Yeah. Could we, instead of embedding them right away, could we just store them for now in like a normal Neo4j way as entities? Could we do that to start?
We should be able to.
Right? And then we have those entities, and we can embed them however we want.
Yeah. Okay. Yeah, let's do that. Let's see. Neo4j save. And just look at how we do the save piece. Okay, we have our domain classes defined. Great. And of course, that's just reading. Not helpful. That's the other thing. I have found it challenging to find examples of write. Like you can find tons of examples of read. It's really hard to find examples of write.
Why?
I don't know. That's an excellent question.
But is there this repository pattern? I don't think so, right? Because that doesn't work with object across. Yeah?
Yeah, there is. Okay. I'm trying to look it up right now. You can use just the plain driver.
There's a OGM recorder, but I don't know if that is the right thing. Runtime recorder for all things. Okay.
So this just says you do a session and you save. In their case, they have a person. So we would just save like probably file metadata.
So a session driver, OGM session, okay.
Right. And I don't think you have to extend though, you just inject it.
Oh yeah. Okay, so where do we need this? Not here, the retrieval service, no. Oh yeah, yeah. That was pretty direct. So we want to have that in, yeah. Sorry. File watcher, that's what most of the work does. Go. Ensure metadata, that was the actual line. So at this point, it looked for existing metadata. Yeah, so what we want to have here is we inject a session for a file metadata, and we call it session, whatever that means so far. Nope. Neo4j session, no. It says, oh, it doesn't have a type. Oh, sorry. Okay, so it doesn't have a type. We just take it as a session. And we try to get something out of it. Begin transaction. Can we load something without? Yes.
Yeah.
And now we want to have the file metadata class, but we have to look for an ID, and that would be this one. At least that was the old implementation of it. Yeah. Oh, okay. That could work then.
Yeah.
So the path of the file is the ID, and it loads this, and then we'll get existing. Oh, yeah. Let's do this. Cool. Sounds good. And then we want to actually save something. Ah, easy. Save metadata. Yeah, okay, so there was some logic in this, probably. Yeah. Okay. We can't use the tags here. And does it need? Yes, it needs to return this. Perfect. No, almost. So it's provided void. Oh yeah, void. Okay, doesn't return this one. And now we return this. Okay. So if all goes well, here it's loaded and here it's stored.
Yep.
A question that I have, because I used Eclipse Store so much. So if I store that file metadata and maybe the file metadata already has chunks. Are the chunks saved with this method? Or do I need to explicitly save them as well?
Yeah, you'll need to capture the, because you still have to take the document and chunk it up. And that's where the Lang-Chain4j, that text segments, come into play, because it will divide those up. So now, this will just save the file metadata, and the chunk will be null. It'll be empty. So it'll save the file metadata entities out there, but it won't have anything connected to it right now.
All right.
Which is okay for a first start, or for just a step one.
So that's the insurance of metadata, and then it just makes sure that this is stored. And now on file change. So we don't want to have that UUID anymore.
Right, but
what we actually want the complete object now, because we don't want to handle that anymore. Hopefully. Okay, so we get this here, and then we are back where we started at our embedding service. Right?
I think so. Except what doesn't it like? There's red squiggly lines. What isn't it happy about?
Probably, because I had this. I just wrote my ideas down. Okay. We want, what do we want? So we have the file metadata now, but we don't have any file chunks. What we could do is use our embedding model to actually get our file chunks. But do we want to do that explicitly, or is there something, some way?
I would have thought there would be a much easier way to do that, but I have not found it yet.
Yeah. So we do it like this. Maybe there's something coming out of this, at least.
Yeah.
Maybe it's not the most elegant way, but that doesn't matter as long as it's working.
Yeah.
Okay, so we are building that text segment. We don't want to add this to the embedding store right now. This is not our use case anymore, because that's what this one does, the writer.
Right.
But we do need to embed this.
Yes.
And now we don't have a file chunk. We have to store those file chunks first and then put it in the graph document, right?
I don't think you have to store them. You would have to chunk them and then create a list of file chunks probably. So like it would be, I think, let me see if I can locate it. Mm-hmm.
In this embedding, there's a vector. Might that be interesting?
Possibly. I think that would return just the vector value.
Yeah.
So correct.
But that would be, so
we
could...
I see what you're saying.
We can create this. Yeah. No. What is it? Values vector, damn it. Vector. So this way I could at least create a vector.
Yes.
That would be
and
enough.
Basically store it, yeah, and then add it to the entity itself. So create like a new chunk.
Yeah.
Right.
Yeah, but one problem we have is this text segment is not chunked. So this content is one big chunk. I don't think that's a good idea, right?
Oh, I see what you're saying.
Because that's what the injector did. It chunked files up, but we are not using the injector anymore.
Right.
Maybe we should use it again. That's that one. Yeah, embedding store ingest. Document splitter.
There we
That's
go.
what we would need.
Yes.
But we can't use this one.
Right, because it's looking for a list of documents.
Yeah, and it also ingests the stuff in the store. We don't want that. Right. We actually just want the document splitter. Maybe there's a document splitter.
Yeah.
Okay. Oh. So builder, yes.
So I have noticed this about Lang-Chain4j is that if you don't use the predefined process as they have predefined it, then you have to very manually do each individual step. Like there's no way to like customize or like tweak one piece of the workflow. It's all or nothing. You either use the entire workflow as it is, or you define your own like unique, very manual workflow.
Yeah. Is that different in Spring AI? Is that more customizable?
Yes.
Okay.
Now it's not 100% customizable. There's still some pieces of it you have to manually configure, but I feel like that is more abstracted in Spring AI than what it is in Lang-Chain4j. And maybe that's just a difference in the design of it, is that they want you to be able to have those lower level accesses in Lang-Chain4j, and Spring AI, again, they try to abstract that from you. But yeah, I have noticed they are different in their approaches.
I don't find a quick way to... No, this one. This one should do it.
That should be what we need.
Splitters. Yes, of course. Splitters. Okay, and then we can probably say this one.
Yeah.
Very good. Ooh, okay, now we can split those.
Yes.
Yes. We still need a document. That should be all right. I can just create a document of the content. That's not
yeah,
the problem.
that should work.
And we get now, text segments.
A list of text segments. That makes sense.
Okay, and now we don't want this one. We don't need this anymore. But we have to get over those with for each, basically. And then we can store those somehow.
Yeah.
Text segment. We create a.
Probably need a list. Or maybe like a.
Oh, we can do a map.
There we go. Yeah.
And then return a new chunk. Right? Or is it?
I think so. Yeah, and then place the content or the text segment in this case. And then the vector. So you'll want to create the text segment as one of the properties, because what's in our chunk entity? What are our properties defined?
There's the text.
Text and vector.
Okay. With the ID. Oh no, my mouse is gone. Oh God. I thought this is all going black again.
Yeah, momentary panic.
The UUID. Do I need to define that? No, that's what Neo4j does, right? If I store it, then it creates
correct. Yeah,
ID.
it should. Yeah. It should automatically generate that. Actually, you could add it. Well, that's in Spring. I wonder now if they have not generated value in LangChain or in Quarkus.
I think. Yeah. See, they do.
Oh, perfect. Okay, then that's probably what we need, because that will tell it it's a generated value, and so it will create it. And you want it, there should be like a UUID type.
Oh, yeah.
I believe.
Well, the type, what's the strategy?
UUID strategy. There's a UUID strategy, actually, that popped up. I think. That's okay.
Strategy. Oh, yeah. Oh, cool. Okay, but so still, this UUID is set after I stored the entity, probably.
When it gets stored, yeah, it'll automatically go ahead and create an ID for it.
So what I need is a constructor, but without the UUID.
Yeah.
So
there.
Good. Okay. And if we create this new one, we need the text
segment.
And we actually. So this is the whole content, not just the one that's chunked. No,
it would just be the chunk. Text. Just the text segment. Yep.
Yeah, and then the text, I think. Right?
No, I think just the text segment itself. Yeah, because you're mapping the list of text segments, and for each text segment in that list, you're saying create a new chunk with that text segment as the text. So you can just erase the .text at the end.
But it's not a string, and we need a string here.
Oh, that's true.
Oh yeah, we need a stream. Okay, that's why it doesn't work.
That's happier.
Okay, yeah, and now I think there's this property.
Okay.
And then
what doesn't it like?
What's the next one? The vector. Yes.
Yeah. So why is it complaining about that?
Maybe because we are not finished. Damn it. Provided well? No, we don't get it. Huh? This is returning a value.
Oh,
why?
Can we can we just send, can we do embedding dot, is there like a to vector? Could we just like reference embedding dot something?
Oh, okay. Sorry. Embedding vector. Yeah.
Yeah. Could we just do that?
Yeah, that's what we did here, but that just gives us a float. that's not what we need. We need a internal. This looks good.
Okay.
If we do this, wait. Oh, okay. So this could work. I don't know.
It looks happy at least.
Yeah. Okay, now we mapped it to chunks, and now all we need to do is add those chunks to our file. No, do we need to add this? Yes. No. 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 Okay. There's no relationship from file metadata to chunk. We designed it exactly the other way around. So
correct.
What do we do with all those metadata things? We actually want to create this for each node. Okay. I'm just trying to work through this.
Yep, that's fine.
So we have this chunk now, and we actually want to have a session where we save that chunk.
Yep.
And it's from chunk class, something like that. And we need to have inject session, this one.
Yep. Driver session.
Right. Yep. Okay. Doesn't save? No. Store? No? What was it? Huh? That looks different. What? The file watcher service does some storing as well. Load? Save? Session? Is that no? Session. This must be a different session. Yeah, that's the OGM session now. And now it works. Yeah. Okay.
There it goes. There it goes.
So we can't
wait a minute, that looks right.
Yeah.
Wrong
okay,
input.
so we save each chunk. Yep. And now every chunk has an ID, and we can store that in our graph node. Maybe. But we need those. Damn it. Okay. And to list chunks. Yeah, because we and okay. Whew. Hopefully this is done now. So we saved all the chunks, and we already saved the file metadata. So after all of this, which we probably need that if we can inject this, right?
We need a reference somehow between the file metadata and the chunk nodes, though. Right?
The metadata. But isn't that
it needs to know
here?
Yeah, but how does it know which file metadata belongs with the chunks?
Well, all of these created chunks belong to one file metadata.
Yes, you're correct.
Right?
Yeah.
So we can throw this away if it works. I'm not sure if that's working. Huh? Well, let's just see. But this one, I have no idea. The label was the file metadata? Or is that...
I think those, well...
what was it before entity? So the GraphWriter should be able to write different nodes, not just one type of node, but
Correct.
everything that's defined here is for one node.
Yes, you're correct. I've noticed that too.
Is that maybe that like the node that's searched on?
Let me look at that GraphWriter. I wonder if it creates a generic label, but then it wouldn't know how to, like basically a default or a dummy label for entity. Because I know we do that a lot when large language models do extraction. They'll create like a generic label for everything and then go through and actually add specific labels depending on the tagging. But I wonder if that's what it's trying to do. I'm just not 100% sure.
Yeah. Okay, I just leave it at that and just want to try. Well, you can go ahead and search if you find anything, and I'll just make it compile for now.
That sounds good.
So I have all these chunks, and I want to actually map them to a graph node. And I can do that this way. But it's not an ID, it's... Oh yeah, I don't have any getters. So this is the ID. And then to set. And then that's it. Yeah, map, then collect to set, and then, okay. Oh, document. No. From set of graph nodes. Ah, okay. And set of graph edges.
Okay.
Okay, I don't know what that is. Let's see. From graph edge. Jennifer, I don't know how much time you have.
Yeah. Yeah, this is way more complicated than what it should be.
Yeah, I didn't think it would be that complicated. Otherwise, I would have prepared much more of the structure already.
Same. Yeah. Okay. Yeah, I think what's throwing me is that there doesn't seem to be a straightforward way to save like the object map. So basically I have a file metadata that should map to related chunks, and you should be able to save that all in a single save. Say, here's the path I want to save the whole path. And I'm just not finding good examples of that in order to do that. I'm finding all kinds of retrievers. I'm finding ways to save like specific properties or just the embedding or the text chunk, but not like the whole graph, the whole entity or the path.
Yeah. And that would be the point.
Right, exactly. Yeah, that's the entire point of using a graph, right?
Oh, okay. So maybe we are too early here in this process. Can you tell me, is there an easier way to do that in Spring AI? Did you try that there?
So I have saved entities. I'm trying to think if so I did I think I did well, the Tika document example, I think, was just the chunks itself. And when I've saved, I've done saves of like the entities and the relationships themselves, but I don't think I don't have a great example of showing that plus the embedding store integration as well. So I've saved the individual graph pieces, which is what we're trying to do. And I've stored the embeddings as chunks, but I don't have a great example of doing that all in a single go. So maybe that's the next piece, is to see how we can save that all in a single dump, basically, to push that all to the database.
Yeah, that would be pretty cool.
Yeah, agreed.
That would be possible. But I think for now we are way too far off that goal to finish it today.
Yeah. So there must be an installment B then.
Yeah. There must be. So can we kind of summarize or end with something that's working? So if we leave out all that embedding for now, maybe we can at least see that entities are getting stored, because that's what
we could do the saving of the chunks.
Right. Oh man.
We would just leave out the embedding, or the
this one, right? The knowledge graph, because we don't know if and how that works.
Yeah.
Get these chunks. Okay. This one is empty and we never get any. Well, that will probably just not work. But everything else could work.
Yeah.
So let's try to compile. Let's stop this, build it again. Oh no, there's something. Yeah, that's all right. Okay. This is probably some list of, no? Oh no, it's a string. Really don't know why this is so slow. Could be that I'm running the Olama container already. Maybe this is a problem. Okay. Build the backend, because I would really like to see this browser.
Yep.
That's something I would be.
So you'll just type in the not secure.
Secure, exactly. Oh yeah, we should be able to connect already. Maybe refresh. This is running.
Yep.
Okay. So far so good, but I think the backend still wasn't happy. Bean info. Oh, what's this? Ah, okay. The embedding service. I probably referenced something. Unsatisfied dependency, but what is the core of all this embedding service now?
Oh, is there still a reference to the Neo4j graph?
Session qualifiers.
Is there still?
This, I think in the embedding service, this one. Did you mean that one?
Yeah, that one.
Yeah. Let's just start it right here. So there's nothing in this yet, unfortunately. Okay. And this is downloading all the dependencies again. I mean, I could start this as well. This is probably a bad idea too.
Something will come up that, hey, there's already something running on the port.
Probably, yeah. Oh man, oh man. Okay, it's compiling. Okay. Let's stop this. Okay, and it can't
dependency.
Embedding service. But what's in this? The session. It can't inject the session. Do we need to configure something maybe for the session?
Perhaps. Let me see if I can check that.
Oh, load serializable. Do classes need to be serializable?
I believe so.
Maybe that's a problem because our classes aren't. Not sure if this is really the problem, because that would be a very strange
that's
error message.
I haven't had to do that.
But do you use that OGM a lot?
Yeah.
Okay. There's something. Okay. The same thing again. The session.
No.
Qualifiers. Unsatisfied no. Man, oh man.
Instead of injecting session, could you inject driver?
Sure can.
And then just call the, well.
This one? and then get a session from it.
Yeah.
For a class.
Wow, that seems, man, that seems so manual.
Yeah.
It should not be that difficult.
Oh, okay. No. But with this session, we have to write that. That's
correct.
cipher.
Yeah, and that's not what we need. Now, see, this says it's an OGM session that provides the bean. And then you should just have to session.save. So what we had should have been correct. Is it? This is application scoped, correct? And then yeah. And the inject session was an OGM session, correct?
Yes, it was, because otherwise we could not use save.
Okay. Right. Oh, right.
So load all. Okay.
What are we saving? We're saving the object, correct? The whole object? The whole file metadata? Or the whole chunk?
Yes, we are. Where is it? Here we go. The chunk in this case. Yes.
Yeah, which should be correct.
I think. And it doesn't complain about this method. It doesn't even come to that method.
So yeah, it's something with the... Hang on.
Maybe we need another dependency for it. Like this OGM. Be used on top of Quarkus Neo4j extension, but no, this is an extension. I don't have any extension. Because that's something different in Quarkus, I think.
The main driver extension, it says, is a Quarkus Neo4j.
And how do we add this with Maven? Add extension. Isn't there any other way? Yeah. Well, okay. Let's just try this. No. No. Okay. Stop this. Oh, because I'm not in a terminal. Okay. Paste. Okay. It does something. Oh, it's downloading a lot of JAWS. Did it change anything in the POM? No, that was us. Us. That, well, I'm not sure. Definitely did not change this, but this might be just formatting. Oh, well, okay. Whatever it did, we can try it again.
Okay.
really wonder what it did, because if we can't see it in the Git repository, then there must be something wrong. Huh. So one last try, and then I think we have to give up for now. Okay, now it's starting, and
same error.
Yeah.
We're missing something.
Yes, we are. These sessions. Yeah. Okay, but I'm sure that is something I can figure out at some point. All right. So that was very, how do you say that? Humbling.
Yes, certainly.
But still interesting to see what you have to do to get that right. And I mean, we try to do it manually, and these libraries somehow should do that someday in the future without all that manual labor.
Yeah.
But it's still interesting to see what needs to be done to achieve that. So that was cool. Yeah, I just wanted to compliment you on that that podcast you have. I find it really interesting. So
great. Thank you so much.
Like it seems like you're just talking away what you did like the last week or something. Is it weekly?
Usually,
so,
yeah,
right?
Yeah. I try to keep it weekly. I don't always succeed, especially if I'm happen to be on the road for an event or something. But yeah, I try to have a weekly episode and just whatever I happen to be working on that week. So, or things that I come across that I find really interesting. I can already tell I'm gonna have a nice long dig in session on Neo4j, and actually how to save the graph to Neo4j now. So if it doesn't happen for this week's episode, hopefully next week. But great. Yeah, it's just whatever I happen to come across that I'm working on, or challenges that I have come across, and hopefully solving those as well. So
yeah, that's really nice.
It's a lot of fun.
And yeah, it sounds like it. One more thing that your colleague, because I looked for you at JCon, and you don't have a slot at JCon.
I do not. Yeah,
but your
I couldn't make it this year. Yes.
All right.
Yep. Michael.
Have you been to JCon?
I have not. That's one of the few that I've known about it for several years. I have several colleagues and friends who go, and it's like, oh, it's on my like wish list. I just haven't made it there yet.
Very good.
So.
Okay, so next year you'll be there.
Hopefully, yeah.
That's cool. Yeah, but I found your colleague. So if anybody is interested in Neo4j, there's one session, and I will have a session as well, and I have to post in a discount in the chat right now, like I think a 15% discount or more. I'm not really sure.
Very nice.
Yeah. Oh, okay. So I will definitely have another session and try this out, and hopefully you can join me again, and we can figure this GraphRAG out.
Yes, because now it's a problem that must be solved.
Yeah, definitely. Okay, but thank you anyway so much for joining me. It was great fun anyways.
Yes, thank you so much for having me.
Yeah, you're welcome. Hopefully see you next time, right?
Sounds good.
Cool.
Enjoy JCon.
Yeah, you too. Well, you too. You next year.
Yes, sounds like a plan.
Okay.
All right. Cheers.
Okay, great. Thank you. Bye.